Okay, hi guys, we'll be continuing on seeing Eudiometry. Okay, so let's get started. So now we'll be seeing what are the causes of contraction in volume. Okay, so let's suppose we have some reagents which are supposed to absorb these gases. So if we have KOH aqueous solution, then this absorbs Cl2, CO2 and SO2 gases. If we have turpentine oil, then this absorbs ozone. If we have ammoniacal CO2 Cl2, then this absorbs carbon monoxide. If we have alkaline pyrogerol solution, then this absorbs oxygen gas. And if we have anhydrous CuSO4, then this absorbs H2OL. Okay, so next let's get on to some question. So suppose we have 10 ml of carbon monoxide which is mixed with 10 ml of oxygen gas and CO2 is formed. Okay, so you have to calculate the contraction in volume in the following cases. Calculate contraction in volume when first we have 100% yield of reaction, okay. So in this case we would be having COG plus H2O2 G, or rather not H2O2, we are just having oxygen. This would be forming CO2 gas. So let's balance the reaction. It would be carbon and half mole of oxygen would be there. So 10 ml of carbon monoxide we are using and 10 ml of oxygen we are using. So this was the initial stage. In the final stage, what will happen? This would be exhausted. 5 ml of oxygen would still be remaining and 10 ml of carbon dioxide would be formed. Okay, so contraction is just negative of delta V, which is V final minus V initial. Hence contraction is V initial minus V final. So V initial was 10 plus 10 and V final was 10 plus 5, because 5 ml of oxygen is still remaining, so the contraction would be 5 ml. Okay, next let's see when we have 75% yield of reaction. So in this case what will happen? So in case 75% yield of reaction, we would have again COG plus half O2G will convert into CO2G. Now initially we only have 10 ml here, 10 ml here. So now ideally it should form 10 ml here, but only 75% is the yield, hence 0.75 would only be formed and oxygen would still be remaining as 5 ml here and this would be consumed. So the contraction would be, again contraction is Vi minus Vf. Vi is 10 plus 10, Vf is 7.5 plus 5. So this is nothing but 20 minus 12.5, which is 7.5 ml is the answer. Next let's calculate that for 10 ml of gaseous hydrocarbon on complete combustion gave 30 ml of CO2, and it was found that it requires 40 ml of O2G. So you have to calculate the molecular formula of hydrocarbon. Okay, so we have CXHY plus X plus Y by 4 moles of oxygen reacting to form X moles of CO2 plus Y by 2 moles of H2O. Okay, so we have 10 moles here, or 10 ml here, and this on combustion gives, this actually requires 40 ml, and on combustion it gives 30 ml of carbon dioxide. So we can easily see the first equation would be X plus Y by 4 multiplied by, so you can see here is that tan X would be equal to 30. Okay, because you can see that all the moles of carbon atom which are getting burnt are coming from carbon atom only. So applying POAC on the same, you can get that 10x ml of carbon is actually getting burned up to get 30 ml of carbon dioxide, in which carbon atom is also there. Okay, so X would be 3 from here. Okay, so now when X is 3, and one more thing to notice here is that from the Y by 4 moles of oxygen, you are getting X moles of, or rather 2x moles of oxygen and Y by 2 moles of oxygen here. Okay, but this correlation won't be helping us here. Okay, so even if we write it like all the oxygen atom which are coming from X by 4 here are getting, this is O2 is getting converted into X moles of O2 plus Y by 2 moles of O. Okay, so again to convert it itself into O2, these two would be same. So this analogy won't be helping us here, but rather if we make another close observation that we are getting X is actually replaced by 3 and we are getting 30 moles here. Okay, so this X plus Y by 4 should be 4. Okay, so because 10 ml will react with 40 ml of O2 if the stoichiometric coefficient of X plus Y by 4 is 4. Okay, we know that X is already 3, so this implies Y equals to 4. Okay, so answer of hydrocarbon would be C3H4. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples on the same.